Welcome to This Explainer. Today, we're demystifying something you've probably heard a lot about, prompt engineering. For a lot of people, interacting with AI still feels kind of like a casual chat. You type something in, hope for the best, and see what happens. But if you really want to unlock its actual power for operational excellence, we need to shift our mindset. We need to turn that casual chat into a formalized, highly intentional process. We're going to break down exactly how to do that, and then we're going to look under the hood to see the actual mechanics of why it works. Okay, let's dive into this.
Here's our roadmap for today. We'll start with the language of AI, look at the anatomy of a perfect prompt, go inside the AI brain, and finally trace the journey from words to math.
Section 1. The language of AI. English as code.
And this brilliantly illustrates the stark difference between an amateur and a professional approach. On the left, we've got this super vague instruction. Analyze this data and tell me what to do. It's way too broad. The AI is literally just going to guess at what you want. But look at the right side. We've defined the exact role, the specific problem, the data source, the required output, and absolutely crucial constraints like assume no additional staffing. This isn't just a request anymore, right? It's a piece of engineered logic designed to solve a real business problem.
Treating prompting as writing code fundamentally changes how we approach this. Instead of using traditional programming languages like Python or Java, we're using natural language. English is our interface now. We might not be writing in Java, but we still desperately need that exact same level of rigor and discipline to connect what we want with what the AI can reliably deliver.
Section 2. Anatomy of a perfect prompt. The building blocks.
So the very first building blocks are context and clarity. Think of this exactly like briefing a colleague who just walked into the room blind. The AI needs to know who you are and what the general background is. You wouldn't just say, hey, write a shoe description. No way. To be perfectly clear and minimize any confusion, you'd specify, write a 150-word product description for a waterproof athletic shoe with significant arch support, available in 10 colors and designed for urban commuters. Giving that level of clarity drastically increases your chances of getting a precise response on the first try. Next up, you need specific instructions and presentation. You must explicitly ask for what you need. Is it a summary? Is it a translation? A deep analysis? Tell it. And honestly, just as importantly, tell it exactly how to present the information. Ask for it to look like a consulting slide with short headlines and crisp bullet points, or maybe you need a memo written in the tone of a friendly advisor. Detail the structure up front so you don't have to waste time reformatting the whole shebang later. Now, this next part is absolutely vital: scope and constraints. You've got to define the boundaries. Telling the AI what not to do is just as important as telling it what to do. You might constrain it by saying, use only the provided information or avoid certain recommendations. In automated business workflows, where AI outputs might feed directly into downstream processes, this is exactly how you control risk, reduce variation, and stop errors from propagating at scale. Rounding out our perfect prompt anatomy is format, tone, and style. When you standardize the format, say asking for a structured table, you significantly reduce the cognitive load for whoever is reading it. It allows your prompt to act as a reliable process design artifact, one that can actually trigger standard operating procedures. And the tone? That controls the voice. You need to match the intended audience, whether that's an upbeat, casual reminder for the nursing staff or a very professional, pragmatic explanation for a missed project milestone.
And hey, remember, you don't just write a prompt once and throw your hands up if it fails. Not at all. Prompting is a continuous improvement cycle. You review the outputs, you identify any gaps, and you iteratively adjust your context or constraints to better align with your workflow goals. Treat your prompts as evolving, improvable assets. Build reusable templates for things like root cause analysis or workflow design.
Let's move to Section 3 and see how this builds. Inside the AI brain, mechanics of LLMs.
The absolute best analogy for a large language model is a phenomenally well-read friend. But here's the catch. This friend doesn't actually know any hard facts. If you asked them what they had for breakfast, they'd probably guess oatmeal, just because statistically that's a highly likely answer. Instead of facts, they have this incredible memory for the structural patterns of how words and ideas connect. They answer based on the relationships of literally everything they've ever read, not by pulling a specific file from a filing cabinet.
Which naturally leads us to a pretty fascinating question. If the AI doesn't search the live internet, and it isn't just looking up hard facts in a traditional database, how does it actually know the answer? How is it creating such a credible response from pure patterns?
That brings us to Section 4, From Words to Math, the Token Journey.
Okay, let's dive into this. The journey from human intent to machine output happens in 4 highly sequential steps: tokenization, vectors, self-attention, and output generation. Let's break these down one by one.
It all kicks off with tokenization. The very first thing the large language model does when you hit enter is decompose your prompt into smaller, bite-sized pieces called tokens. If you ask, "What is the status of my order?" the model chops that sentence down into individual words or even characters. It does this to make the text easier to process algorithmically.
Now, what's really interesting about this is what happens next. Those tokens are converted into vectors. Imagine a massive, invisible, multi-dimensional map of ideas. The AI translates your tokens into a list of numbers that act as literal coordinates on this map. Words with similar meanings, like bank and credit union, or nurse and doctor, they live close together on this mathematical map. The meaning is represented mathematically, not linguistically.
Once those coordinates are set, the AI applies something called self-attention. Think of this just like a crowded business meeting. In a noisy meeting, you naturally filter out the background chatter and hone in on the crucial agenda items, right? The AI does the exact same thing. It mathematically compares every single word to every other word in your prompt, scoring them for importance. It's figuring out which words matter most to establish relationships and capture the true context of your request.
And all of these steps? They're powered by something called the transformer. This is the core engine of the whole operation. It applies that self-attention process across multiple layers, continuously updating the vectors to build a really deep understanding of your input. And then, and this is the big takeaway, it mathematically predicts the very next most likely word based purely on probability. It builds the response token by token until it forms a coherent answer. It is guessing based on math, not reasoning based on human intent.
So, the crucial point is this. When you finally understand that the AI is mathematically predicting patterns based on tokenized maps, you suddenly realize why common prompt mistakes are just so destructive. Writing vague instructions, failing to provide sufficient context, omitting those essential constraints, or worst of all, treating the AI's probabilistic output as a final factual answer without human validation. These aren't just minor typos. You are fundamentally failing to give that transformer engine the mathematical guardrails it desperately needs to calculate the correct pattern. Understanding this data science actually helps you prevent these very operational pitfalls.
Which leaves us with one final, incredibly important thought to chew on. If AI doesn't actually comprehend meaning the way humans do, but rather merely predicts patterns based on mathematical probability, how will you redesign your daily business workflows to ensure that you are always the one controlling the final meaning? Thank you so much for watching this explainer, and I really encourage you to start applying this engineered mindset to your very next prompt.